All right. Hello, Belgium. Hello, DevFox family. Thank you very much for the invite. Thank you very much for joining my talk about what comes after Git. Who am I? My name is Christian Schabetsberger, but you can simply call me Chris. It's probably a lot easier for you. I'm a freelance software engineer and software architect. A company is called Fixit IT Solutions. I'm actually doing mostly C#, .NET, Angular stuff nowadays, but I'm a freelancer. If you pay me well enough, I will even do PHP. I'm also the organizer of the .NET meetup in my local town in Linz in Austria. And I'm on the internet. That's the computers with the blinking light that talk with each other. So if you want to reach out to me, if you have questions, suggestions, whatsoever, I'm on Blue Sky, I'm on Mastodon, I'm on LinkedIn. Feel free to ping me there or just talk with me. I will be around for the rest of the conference. Enough about me, I'm not that interesting. Let's talk about version control systems. So who of you here dares to not use a version control system, like at all? I see no hand. That is wonderful. You would be surprised. I know 2 companies who are living that way. I don't know how to survive. Who of you does not use Git as their main version control system? Oh, a couple of hands. Wonderful. What are you using? Sorry? Subversion. Wonderful. Nostalgia or Okay. That almost aligns with the data we know from a Stack Overflow survey of 2022. We can see that Git has a market share of nearly 94%. So a couple of people, Subversion, that are sitting here in the 5th row. And there are some people that don't use a version control system, but we have to note these are overall respondents. So including people still in education at university, not everybody there is using version control systems, especially in the very beginning. So if we switch over to professional developers, we see Git has a market share of almost 97%, again, still a little bit of Subversion. Then a couple of people who still don't use a version control system. And then there are a handful of people that are using Mercurial. We will be talking about that later again. So I think we can all agree that Git is the main superpower in the industry. But it wasn't always like that. Git was neither the first version control system we had, nor was it dominant from minute 1. I brought you a word cloud here with many different version control systems our industry has seen over the past 50 years. So Git itself built up its reputation over years of hard work, learning from previous failures and successes in the industry. But how did it happen? And what will it take to replace it? To predict the future, we need to understand the history. I don't have a TARDIS with me here today, but I want to take you on a little time travel journey back into the 70s, when we got our first standalone version control system, which was SCCS, the Source Code Control System. I brought you some sample console logs here on the right side. I will not go into detail of those, but feel free to check them out by yourself. You might find some reused commands, some reused patterns along the journey. 1973, Mark Rutschkin, who worked at Bell Labs back then, developed the first version of SCCS, the Source Code Control System. It was file-orientated, log-based, and only local with no network capabilities whatsoever. And it dominated our industry for decades. Well into the 90s, it was so important it even became part of the single Unix specification, making it available on all Unix systems out there. Let's jump ahead into the 80s. In 1982, Walter F. Tichy, who worked at Purdue University back then, developed the Revision Control System, RCS. And although licensing initially prohibited the distribution of it, it gained quite a bit of traction the following years when that was changed. It had very similar characteristics to SCCS, being file-orientated, log-based, and local-only, again, with no network or collaboration capabilities. But it worked with something new. It used so-called reverse and forwards deltas, so to improve the speed, because they had the opinion that the latest version is always the most important one. All the history is kind of not neglectable, but not that important. So the latest version is always the important one. And that is very unlike. So this is a delta-based version control system versus snapshot-based version control systems like SCCS or Git. Again, a jump ahead into the next decade. In 1990, Dick Gruen developed the concurrent version system. which was originally planned as a kind of front-end for RCS. That quickly changed, however, with the popularity of CVS, and later it only shared the internal data structures with RCS and became its own thing. Characteristics of CVS include a merge before commit strategy, so quite the opposite to Git. In Git, we have a commit before merge strategy. And it started to support repository level tracking, so multiple files. So not only single files, but multiple files. However, those operations were not atomic. So if something failed after file 7 out of 10, you could corrupt your repository. Obviously, not awesome. We are, however, now in the generation where collaboration becomes part of version control systems with client-server architectures. One last jump ahead, and we now arrive in the Neolithic Stone Age of version control systems. In the year 2000, BitKeeper was released. Being proprietary software, adoption was mainly focused more on enterprise-y customers. However, their CEO was a big supporter of open source, so they handed out free licenses for open source projects. And so the Linux kernel adapted it in 2002 and used it all the way till 2005. The main groundbreaking thing was that BitKeeper was a bit ahead of its time, I think. So it was the first to offer a fully decentralized development experience as we know and love and sometimes hate it nowadays from Git. It uses a commit before merge, again similar to what we do in Git nowadays, and it had support for file sets while also being atomic. In the same year, Subversion was about to see the light of day. It was the most compatible successor to CVS, allowing an easy migration path forward. And we have seen some people are still using it today. Again, probably more for legacy reasons than for nostalgia. While supporting a merge before commit strategy, this was the time where developers were very much afraid of creating 2 branches. Because now you have 2 versions. And how will you ever integrate that back? Impossible. So most people worked with locking files on a centralized server, which is a lot of fun when your coworker checks out the file and leaves for a 3-week holiday. You can ask the guys on the 5th row. Of course, it also supports file sets while also being atomic, so that is becoming a standard at this point in the year 2000. We're now in the year 2005, the birth year of Git. And was created by none other than D. Linus Torvalds himself. Everything began with the adoption of BitKeeper for the Linux kernel development back in 2002. BitKeeper, being proprietary, wasn't exactly very well received by everybody in the free as in speech open source community. So it was only a question of time till it would become a problem. And in 2005 it did. Andrew Tritgell, an Australian software engineer, reverse engineered BitKeeper and published his own software called Source Puller, ultimately causing the BitKeeper controversy. The BitKeeper engineer said he violated the license. He argued against it. He said he never agreed to a license. Pick your own fight at this point. After all this time, I don't think it matters anymore. Linus Torvalds tried to mediate between the 2 parties for multiple months, but ultimately failed. And therefore, he initiated the Git development and created the first version of Git in just about 10 days. Git itself, of course, is fully decentralized and supports the same characteristics as BitKeeper, as it was replacing it. And in the same year as Git, we also got Mercurial. And I think Git was in like April, Mercurial was around October, so just a couple of months afterwards. It was created by Olivier Mackell, and it has a very similar story to the one of Git. It was created in response to the BitKeeper controversy, and it was created for the Linux kernel development. However, Linux kernel mailing list decided to use Git instead of Mercurial. Mercurial is also fully decentralized. Again, has also very similar characteristics to BitKeeper and Git, but it has a few special ones that I want to name because they will affect us later down the talk today. It works with anonymous branches by default. It uses bookmarks instead, and it has this kind of change set language. We already saw in the data that there are still some people out there using Mercurial, and they're probably working there. So this is a very famous blog post from 2014 published by Facebook back then, I think. Nowadays they're of course called Meta. And they described on how they adapted Mercurial for their use at Facebook. Other high-profile projects like Mozilla or the OpenJDK have however left Mercurial behind and switched over to Git 2. To wrap up the history, I think we can categorize them into these generations. First, we got local single-file only systems like SCCS and RCS. Then the centralized age of collaboration took over. And finally, we are currently in the distributed generation of version control system. But how did Git become so dominant? Why was it not Mercurial or Subversion? I think there are two reasons. The first one is kind of obvious. Git was not only used, but invented by probably the biggest software project our industry has ever seen, a Linux kernel, giving it a big head start regarding adoption. And while Mercurial has a similar backstory, I think Linus Torvalds being the one to initiate the Git development was a very big reason why the mailing list decided for Git instead of Mercurial. But Linux is not everything, right? I think the second reason why Git became so popular are those guys, GitHub, or the free hosting of source code. We had that before, of course, but GitHub really pushed the Git part of that. And other solutions like GitLab followed quite quickly, and even more enterprisey application lifecycle management tools like Bitbucket, which originally only had support for Mercurial, added support for Git, and they even dropped Mercurial support now in 2020. And even Microsoft with their Azure DevOps, or whatever it's called nowadays, Team Foundation, no, that was the old one, they renamed it a lot of time, they added support for Git next to the Team Foundation version control. So we're here 20 years later and can say happy birthday, Git. So Git turned 20 this year in, I think, April, May, June, something like that. But what happened the past 20 years? Why is Git still being so dominant? We rarely see a software survive in our industry for 20 years without calling it legacy or wanting to call it legacy. I think it's pretty easy because Git is really good at being a version control system. It does one job and it does the job bloody well. There are still regular releases happening, and improvements in innovation is still happening. Git 2.51 was released, I think, a couple of weeks ago, mid of August. And yeah, it hasn't come the big ball of mud yet. But I think it lacks a little bit of competition nowadays. So let's take a look on which version control systems were released since Git, because the industry is not sleeping. We're never sleeping. There weren't that many, so not a new one every 5 or 10 years, as we saw in the history. But especially in the last couple of years, we had a couple of new things turn up. Fossil just started about a year after Git and Mercurial in 2006, but it hasn't gained any significant market share since then. However, it is developed by Dr. Richard Hipp, the creator of the SQLite database. So it has one very famous and big project that is using it. It's quite nice. It's probably a better fit for like smaller teams. It also has a bug track and a wiki included, so more sort of a little bit full application lifecycle management tool. In 2015, we got Pitchell, and Pitchell would have been quite interesting because it tried to solve the performance problems that Darks had. We didn't talk about Darks in the history because there are way too many version control systems. I had to skip over a lot of them. But it is also a Delta-based version control system. And Darks basically mainly lost because of its performance problems. And Pitchell works with the same kind of idea. They call it the theory of patches. And instead of snapshot-based version control systems like Git. It, however, seems to be relatively inactive nowadays. Version 1.0.0 -beta has been out for quite some while now. There have been some recent changes in their, I'm not sure if they also call it repository, but in their repository. However, not in their size that probably would be needed to push this one anywhere much forward. If you're more interested about fossil or pitchul, I recommend you this talk from Hanno Embrechts from DevOps Belgium, the conference you're visiting right now, and from 2022. He mainly focuses on those two and demos them. And I think you can find Hanno also at this conference. At least I saw him on Monday. Not sure if he's still around, but I'm sure he will be happy to talk with you about those two. I, however, today want to focus on the 3 latest additions, which are Jujutsu, Sapling, and GitButler. Anybody ever heard of Jujutsu? Raise your hand. All right, couple of hands. Sapling? Not that many, all right. And GitButler. Okay, so Jujutsu 1, wonderful. We're gonna start in order anyway. So Jujutsu was created by Martin van Zweigberg, an engineer who works at Google, and he works at, surprise, surprise, version control system. Google famously doesn't use Git or any other version control system or any other publicly available version control system, but they are also rolling their own thing. The special thing about Jujutsu is that it abstracts away its storage and its backend from the rest of the version control system. So for all we know, you could implement a Dropbox backend and use that. Not that I would recommend it, but do whatever you want. But of course, it also supports Git as a first-class backend. They also support the Google internal version control system as a backend, but not that good as Git. I'm not sure if there is anything else at this point. It uses a mentally very different model compared to Git, so all branches are anonymous by default, just like in Mercurial, as we saw today, and there is no index, there is no staging area. Instead, your current working copy is automatically your latest commit. So instead of doing the work and then checking it in with a commit as you do in Git, you create the new commit, and all the work you do is automatically part of that commit till you create the new one. And that allows for, surprisingly, a very much richer project history. Another special feature is that conflicts are not treated as panic, but instead, they are first-class objects. They are part of their data model. You can move on from a conflict and do something else. Check out a different branch. We don't have branches here, but you can work on something different and then come back and resolve that conflict later. You can't do that in Git. In Git, a conflict means either abort or resolve that conflict. All right, so let's quickly check that one out and how it looks in the demo. There we are. So there should be a JJ folder. Right, that's where we're at home. So JJ is the command line utility for Jujutsu. It's quite a nice abbreviation, I think. And we're gonna simply start with an empty new Git repository. You could also do a JJ Git clone here, but I'm gonna start with a fresh repository for the beginning. And when we check out what we have in a folder here, we can see we have a .jj folder and a .git folder. That is quite new. So the co-location of the Git folder in here is something that they've only very recently added. I mean, they had it before, but hidden behind configuration. It's new that this is kind of the default now. Previously, it was only the JJ folder. So you can also see the Git integration here in my terminal is working a little bit, but you will see that will very quickly change as soon as we move on. So if we call JJ now, we basically get a JJ log overview here, so like in the git log -1 is one line. And we can already see we already have 2 commits here. Even though we didn't do anything, we have a magic root commit here and another commit that is empty and has no description set so far. So let's set a description. This is already an important change from like Git. We can set the commit message right now at the beginning. We do not need to wait till the end. So we're gonna do that with JJ describe -m for message, very similar to Git. And then we have to set the message. But of course, it's still empty. So let's create a README file. Say hello DevOps Belgium. Save that. And if we call JJ log again now, we can see that empty thing, that is gone. We have a commit, we have checked in your file. We can already see, well, the terminal Git integration, that one looks weird now. Because we have saved our stuff, but it doesn't really recognize it. Something that is notable mention here is we can see on the right side here it's printing some hashes. So these are the hashes coming from Git, of course. And of course they change because we changed the content of our commit. We set a commit message. We added files to that commit. However, on the left side here, you can see a second identifier. And that one stays the same. This is the so-called change ID. So Jujutsu assigns a so-called change ID to everything you do, every commit you make. And that is quite magic because that one stays the same, whatever it happens. Cherry picking, for example, in Git can be quite cumbersome because, as we all know, the hash will change because the commit of chain of hashes changes. Git is basically a blockchain. So it makes sense that it changed, but of course, if you do something like cherry pick onto another branch and try to merge later, basically all hell will break loose in Git. And the most similar experience you could get in Git here, let's say you do create a feature branch based on another feature branch. The one is refactoring, the other is feature. You already merged the refactoring, but not the feature yet. A Git interactive rebase with update refs and rare enable is probably the closest you could get to this one. It's kind of like that, just on steroids. Basically supports for all the different kind of things. Good. Let's create a new commit. We can do that with JGNew. We could also provide already a message there, but we're going to do a describe again separately with an important change here. And then let's modify the README file because we have an important change. If we check again, of course, everything logged in there into our Jujutsu repository, I almost said Git repository. And now we realize maybe that change was not important. It was, in fact, a very important change. I'm going to check that in again. And then we realize maybe it was not very important. It was just important. Has anybody ever had changes in your local working directory, not committing it, changing something and wanting to go back to the previous one? Be honest. Yeah, thank you, finally. It happens. It has happened to all of us. And this can be annoying, of course. And that is a little bit nice about Jujutsu. So you need to call some kind of Jujutsu command like jglog to check in the files, otherwise it will not work. But we can automate that. We have an automatic git fetch in our IDEs integrated. Could be a very similar experience to automatically do that. Good. So we have an important change, made a very important change, and now we want to go back onto the important change. And we can do that because Jujutsu recorded all those things first. Even though we only see like one commit here, there is a thing called evolution log. I'm going to use the JJ UI now. That is another open source project you can find on GitHub. It's a text-based UI for Jujutsu. Looks like this, very similar to before, but it has some very nice features here. And we can open the evolution log for our commit here. And then you can see all the kind of things we did in our commit. We had an empty commit with no description. We had an empty commit with a description. Then our important change, and then our very important change. So all these tiny separate steps were recorded. And if we really integrate that into our IDE, I think this could be really, really awesome to do this kind of auto commit of everything automatically recorded. In the end, you still only have like one commit. Good. As much as I would love to explore more about Jujutsu, we need to move on a little bit because we have some other players I want to show you. So we're going to go there. Wonderful. So next we have Sapling, which was created by Meta, the company behind Facebook, Instagram, or whatever. And as we already know from the history part about Mercurial, Meta is rolling their own kind of version control system, budget version of Mercurial basically, and Sapling is their newest addition to that chapter. It was released in 2022, generating quite big media coverage back then. That's also what surprises me a little bit about it, because every time I do this talk, Sapling is by far the most unknown of the three new contenders. But back then, very, very big media coverage. And since then, however, we haven't heard that much. It's probably the reason why most of you do not know it. Development, however, is still very much active and ongoing. It's not dead, by far not, probably because Matter is using it themselves. So Sapling itself is Git compatible and has first-class integration with GitHub. Although they also have their own protocol, their own server-side component for it. However, those things are not publicly available. They are probably too tied to the Facebook internal infrastructure. They are working on an open source component there called Monocake, but I checked it again today in the morning. It's not usable yet, unfortunately. And that's a little bit of pity because that would be the really interesting part about Sapling. Because feature-wise, it offers a lot of the same things as we saw from Jujutsu, like no local branches, no staging area. You can easily reorder commits. That's something we will take a look at in the demo. And Sapling targets more like huge code bases by providing a virtual file system for faster checkouts and for faster status commands. So they are attacking the big mono repo space. But of course, you can use it for smaller code bases too. And that's what we're gonna check out now in the demo. So we are right here. So the command for Sapling is called SL. And we can simply do a SL clone with whatever Git remote URL we have. I'm gonna use a repo here that I have prepared. It only contains a README file. Come on, conference. Yeah, already good. Then we can go into the folder here. We can look at. So this time we don't have a .git folder. It's not here. It's hidden somewhere, probably within the .sl folder. And we have a README file. You already know that the content of that one. So this is an open source repository. It should have a license file. We should add a license here. Very important license. And when we call SL status now, we can see, okay, it tells us, hey, there is this license file I don't know about. So again, there is no staging area, but you need to explicitly add files so they get tracked. We can call SL add with the file name. We could also do it with a simple asterisk, but it then will tell you, hey, I'm already tracking that one. Why you're annoying me with that kind of stuff? And we then can do a commit and say simply add license. And that is a very similar experience to on how we have it in Git, I think, with the exception, of course, that we do not really have any kind of local branches. If you call the SL command without any subcommand, and there is a Sapling repository there, then it will basically render a Git log for you here. You can see we have two commits here. The one I created, the one I created before. Let's do that again. And the one I just created now. And it has a very nice graphical representation. It moves over there a little bit, showing that this thing is only locally happening here on my repository. It's not on the remote yet. So let's create a couple of new commits. So I've prepared here something in the history of my terminal. And if we call SL again, what you can see, I just created 3 new commits, basically adding 3 new files, because I want to show you the web component now, and we need something to play around with that a little bit. So this is the actual really interesting part about Sapling, because it comes with this kind of web view. Like there's no desktop equivalent to it, but browser is fine enough nowadays, I guess. And there are some pretty cool features here. I'm gonna show you some of them. For example, there is this edit stack here. And what we can do here is simply drop a commit. Poof, gone. We can drag and drop reorder commits. Simply click Save Changes, and it will do that. And to be honest, this is how I would like to Git interactive rebase to be. Not, I find Git interactive rebase very cumbersome to do. And this is kind of how the developer experience, in my opinion, should be. As mentioned, there is a GitHub integration, which I haven't set up here, but you have a submit button to directly push all the stuff up there. Again, this thing is not available as a server component. They're working on it, but yeah, as mentioned, not usable. And yeah, I would also like to have this one on the server, because that would be pretty cool. Let's switch back to the presentation. And we're going to continue with our last contender for today, which is GitButler. So GitButler is a startup from Berlin. It was founded by Scott Chacune, who was a co-founder of GitHub. GitButler supports, as its name already suggests, only Git. And it is very, very deeply integrated with it. It is the first desktop UI client of our contenders so far. But it is not just another Git UI client, as we have so many already in our industry. But what they are doing, they're not wrapping around the available CLI commands. They define development workflows in the UI and then check on how they can map them back onto Git objects. And that is a very, very different approach on how they develop this kind of software. And I think it's a really great way to approach this one. Just a couple of weeks ago, they also announced the GitButler CLI called But. It unfortunately didn't get a public release yet, so we cannot take a closer look here today. However, there is already a short video out there on YouTube, so if you're interested, you can search for that one and watch that. Jujutsu, GitButler support, come on. GitButler takes a lot of inspiration from Jujutsu, and they say it themselves, they stole a ton of stuff from Jujutsu. Mainly the change tracking ID we already saw before. Also the possibility to resolve conflicts later. They call this one fearless rebasing. And also they have a very rich project history, which they call, I think, operation log, where you can easily revert back to like a previous state of your repository. But you can also roll forward again. So really like a timeline where you can jump around. But it also comes with some new features that we haven't seen so far. And those are, for example, virtual branches and dependent branches. And that's what we're going to check out in the demo now. So we are going to go over here again. And I have already prepared another repository here. So this is the GitButler folder. That is a normal Git repository. It has a .git folder. Again, a README file, but we already know what's in there. And this is how GitButler looks in the UI. I already opened the repository. There's a small little get started guide here, what kind of features you want to activate and all those kind of things. And this is how it looks like. So let's add some changes so we can do something. Obviously, we're gonna edit our README file because we have important changes. And we're also gonna adding a license file again. Again, this is a public repository. It should have a license file. All right, go back to GitButler now. We can see we have the changes here on the left side, so very similar to usual Git clients. But what we can do now is we can simply drag and drop those kind of things onto different branches or swim lanes. You can see it automatically created a branch here, CS branch 1 and CS branch 2. CS are my initials. So just automatically create some branches for you. And we can start with the commit process here. We can generate the message, create commit, do the same thing over here, yada, yada, yada. So as you saw, we just created 2 commits on 2 different branches. Locally, however, still have both changes applied. So we still have the change in the README file, and we still have the license file here. You might ask, how is this possible? What branch are we even on now? Let's check. GitButler/workspace. Very weird one. So they are doing a lot of magic behind the scenes for you. They're currently working on it that you do not need to be on this GitButler workspace branch. So that probably will come very soon, but basically they are creating Git objects for you behind the scenes, applying them, merging them together on some kind of other objects, and then making it available for you on your local working directory. And if you say, hey, I would like to get that changes away now, you can simply click on apply stack here, and it will be gone. The license file is gone. But then you are like, hey, I would like to have my license file back. So we go over to this one here and simply say, where was the button? Come on. Ah, there, apply to workspace. So they recently changed the UI. I'm not very familiar with that one yet. And license file back again here. That is pretty cool, I think. There are a couple of other features like the operation history that I already mentioned. So you can see everything we did so far here in our repository, and there are revert buttons. We could simply go back to that point in time when we did that kind of thing and restore the state of that repository back then. And we could jump back again up here where we created that branch. Let's push those things to GitHub and create some pull requests. So I'm going to create a PR here and also PR here. And again, we can see two different branches, two separate commits, only with the respective changes from that branch. Let's gonna merge that one. There we go. And then we can refetch within GitButler here. We say update, and it will update the workspace, clean out everything for you. Again, it has this kind of change ID to recognize, okay, these are the same commits, so independent of what you kind of do with your merge process. Not sure if they also support squashing at this point, but they will recognize, okay, these are the same changes, and they will simply clean up the whole workspace here for you. Another thing we can do are stacked branches. So I'm gonna simply quickly generate some more changes here. So we have something to do. And let's also go in the license. And of course, all the things are there again. We can simply move them over, but we can also create a branch. For example, a branch above here, a branch below here, and we can move things around quite easily. So let's commit this one here, and then we're also gonna start a commit here. Message, and you can see we can move them between branches very easily. We can merge them together into one commit, and that is, I think, quite interesting, because something that usually happens when you work on a new ticket, on a new feature, is that you do some refactoring, follow the Boy Scout rule, leave the code base better than you found it. But feature development might take some time, the refactoring, you might want to have a separate review for that, get that back in early. And that is quite nice, because then you can just create dependent branches. You can create one for the refactoring, one that includes your feature development that you will work on for a longer time. And you do not need to hassle around with a Git interactive rebase to keep your history clean. GitButler will figure out all these things for you kind of automatically. Good. Let's switch back to our slides. There we go. Wonderful. So as we're wrapping up, we'll come back to the original question. What comes after Git? We have seen 3 new contenders today, and all of them use Git or support Git in one way or another. We saw Jujutsu using Git as a kind of storage engine, as a backend. We saw Sapling being Git compatible besides its own protocol. And we saw a new Git UI client where they define opinionated development workflows in the UI and then map them back onto Git objects. So the answer to the question about what comes after Git might be quite obvious at this point. Maybe it's more Git. We're far from being done with Git. Even after 20 years, I think it's an amazing and a great tool. It works for a lot of different workflows. It's quite versatile in that regard. And all the free tools we have seen today are using Git in some form or another. And we have seen similar things, a lot of happening in the past with version control systems that basically build on top of each other. We saw CVS was built as a front end around RCS. Subversion was the most compatible successor to CVS. And BitKeeper reused the internal data structures from SCCS. It makes them much more likely to succeed and much more practical to evaluate and test out and use them with your existing projects. An easy migration path, of course, will be key for any kind of adoption. And using Git as basically as a storage engine, as a backend, something where Git is really good at and efficient at, that's where most of the development maintenance goes nowadays from the maintainers. That allows to easily integrate them with existing tooling and projects. And it's important because we are getting dangerously close to an IP version 4 versus IP version 6 scenario. We build a ton of stuff on top of Git, like Git version, some companies are doing GitOps. Basically, our whole CI/CD workflows are built on top or around Git at this point. Again, an easy migration path will be key. So what should you do next? Obviously, go back to your company and do something I refer to as conference-driven development. Was anybody in Victor's session about psychology of code yesterday? Raise your hand. Oh, a lot of people. So he referred it to as the shiny object syndrome or the resume-driven development. Go back to your company, replace Git with all the shiny new things you have just saw. I'm kidding, of course, please don't do that. But I'm asking you to be open to explore some new things. Spend some time and experiment with these new tools, try them out, play around with them, and you will learn a lot along the way. Especially Jujutsu works with a completely mentally different model. I'm going to be honest, it took me a long time to grasp it. I'm not sure if I fully understand it even at this point. And the awesome thing is you can use all those free tools without your coworkers being on board. They don't even will notice. It doesn't matter how you push your Git commits to the remote server. So you can try them out by yourself as long as you're installed to allow software. And Git might seem like the holy grail, and probably as of today it is. But there are other ways in life too. And in our industry, rarely one size fits all. That's everything from my side. Thank you very much for your attention. And I think we have some time left for questions. All right, if there are no more questions, then thank you very much again. That's a wrap. Thank you, DevOps Belgium. Have a nice conference. Feel free to rate my talk on the app, and happy to hear your feedback. Thank you.